When you worked on earthquake proofing structures, that's sort of been your drive. How is it that the science of, let's say, random vibrations or a shaking earth,
Mm.
how would you translate that? What is the process by which you translate that into a structural, a stable structure, or as good,
Mm.
as stable a structure as you can design? How would you think through that process?
So, my initial training during the doctoral program was on analysis of structures, the quantitative part. The change was that the practice was doing linear analysis, and I learnt nonlinear analysis during the doctoral program. Now, what we learnt was when Earth shakes, it feeds energy to structures at the base of the structures. We need to know what band is that set of frequencies in which energy is being fed. And that's easy because we have recorded ground motions and we do analysis, spectral analysis. We get the band in which energy is there. So, structures which are having natural periods which are matching with that will really see a lot of excitement or a lot of response on that. So, our job was to see if you are sitting in that band, because it's a one-story structure, 2, 3, 4, 5, keep increasing the height of the structure, the frequency of the structure changes, the natural frequency of the structure changes. And so we can't sometimes keep it away from that window where the earthquake is feeding energy.
Sure.
So you have to stand in there and then face it. Now, interestingly, unlike all other effects, this earthquake effect is different and not taught in colleges. For example, earthquake is movement of the base, and in the entire college education, bachelor's, master's, doctoral, you're told you have a structure, you apply force on it and then analyze. Here we are not applying force. Force is induced.
Correct.
And it's the movement at the base. This is the biggest change, and in India, the subject is not taught in any college. So for us, it became very clear that if 80% of India's population is sitting in the moderate to severe shaking areas, we need to give protection to them. So we needed to bring the subject to a level which is simplified. The first thing that we had to do was to show that you can do hand calculations and still make buildings and structures safe, and that's called the equivalent static method.
Okay.
And then came the dynamic analysis method, linear, and then came the dynamic analysis, non-linear.
Yep.
So our journey of learning the subject over the last 3.5 decades was to actually understand the nuances of each of these levels, the deficiencies, and then try and provide for the next level in a graded way. For mass structures, 95% of the structures are 1 to 3 stories tall and mostly houses and offices.
Sure.
The rest of them are the critical structures, which are like buildings, bridges, water tanks, chimneys, silos, bunkers, all the industrial facilities and so on, towers, coastal structures. There, our approach had to be a little different. And so our attention was first to secure houses and then go into the infrastructure. So we spent almost about 2 decades in fixing the story of the houses. So we worked with practicing engineers and architects to learn where the pitfalls are and where we had made mistakes. And that became the backdrop of the revision of the Indian standards.